So I've opened up LM Studio on my Windows machine. As you can see, I have a 5070 Ti running. And let's use Qwen 3.8, the latest model out there from Qwen. 27 billion model, and kept speculative decoding, KV cache quantization off. And we'll quickly see a demo on different stages, an LLM processing a request in a manner that is very clearly visible, and explain why that is the case. So I have a very large prompt here that I'm going to feed to the model. Uh, it is in this prompt. It's processing the prompt and streaming out the answer. Obviously, it's not so fast on this machine. It's a 27 billion model. But what we needed to focus on was the wattage of the GPU, right? How much it was using, especially during generation and during prompt processing. So that's what we'll focus on next. And here I've pasted a larger prompt. Now, just look at the wattage. During prompt processing, the wattage was much higher, around 180, 170 watts. And then during generation, as you can see now, it's much lower, right? It's at 77. So why did wattage, which is the direct measure of the amount of work done by the GPU, suddenly peak during prompt processing, but then during generation was much lower, right? So we'll see why that's the case. We have the user prompt coming in, right? Which is that large block of text we give. Now, what needs to happen is we need to process this prompt. The model needs to understand what is in the prompt well. Now, how it does it is by attention, right? And what we need to do is calculate its KV cache, calculate the KV cache from it, right? Right. So the KV cache, what can then happen is our LLM. What can then happen is our LLM will then load this KV cache, right? Load the KV cache, run the forward pass. And after a forward pass is run, it will output a single next token, right? Next token, whatever it is, right? And of course, then what happens is it's autoregressive generation. So this token again goes back, extends the KV cache. The KV cache becomes bigger. The KV cache is again streamed to the LLM, and the next token comes up and so on, right? So this is basically a loop until you reach the end of sentence token. So what happens here in the first phase, this phase where we calculate the KV cache for the prompt is called the prefill, right? So this is called a prefill, and this is highly compute bound. What do you mean by compute bound is that since you know KV cache calculation is basically a large matrix multiplication, right? You have to do the dot product q dot k transpose and so on as per the attention formula, calculate the KV cache, and that is highly compute bound. You need to utilize the cores to the max. That is why we saw the power usage on our GPU spike up during the prompt processing stage, because it needs to work full speed in order to materialize this matrix, which is basically a large matrix, one for each layer of the model, right? And then what happens is this is read by the model every time. It is streamed. The KV cache is streamed. LLM accesses it and does generation, which is also called the decode phase, and it is memory bandwidth bound, right? Why is it memory bandwidth bound? Because to generate a single next token, it needs to read the entire KV cache, which can be in the order of gigabytes sometimes. It needs to be read fed into the LLM. LLM will do the forward pass, then generates the next token, and this KV cache, as you must remember, it keeps growing, right? Keeps growing. So that means it can get larger and larger in terms of memory. So that is entirely dependent on how fast your GPU can access the KV cache, right? So that's why it's memory bandwidth bound. And that is not highly dependent on the computational capability of your GPU, right? That's why during decode, when the model is giving out your answer, the power usage dropped. It needs to read a large amount just to generate one next token, right? So that is basically prefill and decode. Contrary to what many people who do not know these things might assume, right? You may think that as the model is answering, it can take up more energy, which is the case sometimes, right? If the tokens per second is very high, of course, prefill and decode can take up similar power usage. But the concept behind them is that one is compute bound, there is memory bandwidth bound, different requirements, all for one task, which is answering your question.